I don't know why there's so many questions. All right.
Sorry, I'm just trying to pull up the little applet.
Yeah, that's on 14.
Is there a link to that anywhere close or no?
Yeah,
but I can't find it.
Lesson 5 group meeting.
Oh, group meeting. That would have helped. I was looking under like individual preparation. Okay. Got it. All right.
Okay.
1 and 2 done.
Okay. So we just copy the thing and plug it in the z-score, right?
Yeah. So it's saying to the right of the 1 point. So we're not clicking the middle. That's all it's saying, right?
So left and right should be clicked, and it's just the area, the 1 point or 0.175.
Yeah. Okay.
Oh, my thing's being weird. Okay, z equals 1.358 is what you got?
Yeah, so plug it in, and then area is 1.74 or 175.
1.745.
Okay.
You got 0.175, you said?
Yeah, 1.75. Or sorry, 0.175. Man.
Yeah, 0.175. All right, we good?
Yep.
Okay, and then something about boats on this next one.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised as after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 127.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this example. Ground answer 3 decimal places, yada, this and that. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are far away from the mean, as ours in the positive direction. Nightmare.
Okay. So. Are we using that new equation then?
The value minus mean divided by standard.
Yep.
Okay, so I'll read off some numbers. So the value. Wait, what would be the value?
Value should be the number of passengers, isn't it?
Yeah, we're just double checking.
And so we have the sample mean minus the mean of the whole group over the deviation divided by the square root of the sample size.
So I'll see if I can figure out the standard deviation real quick.
It says it's 26.7.
Wait, no, N would be 48, right? Because that's the number of passengers.
Yep.
So it's gonna be 27 or 26.7 divided by the square root of 48, which is the bottom part. So then 10. Not 10. What is the
random
sample
sample is
mean?
3.85381.
Do what?
The standard deviation is 3.853 or 4.
It says the deviation is 26.7.
No, he's doing the equation.
Yeah.
Doing it right. 26.7 divided by the square root of the number of passengers.
So 26.7 divided by 48 equals 3.85.
Isn't that the number of passengers equals?
One more
Okay,
time.
so 3.854. So then
Yeah.
how do we figure out what is the sample mean?
Shouldn't it just be in there?
It says the sample mean was determined to be 177.6.
Yeah.
7.6 minus
185.
No, wouldn't it be 185 minus the 177.6?
Yeah, that's what it is. And then divided by standard.
Yeah. Okay, that's right. So we're gonna do 1.7.6 divided by 3.854.
Why is it
1.92?
divided by the 177.6? I thought it was the other way around.
Because the mean
Value minus the mean.
Yeah, because the original value is 185, and then the mean, it just says the sample mean was determined to be 177.6.
The sample mean is what the U is.
That sample mean was the X bar.
Oh, shoot. Good point. Actually, I think you're right. Let me go back to chapter 6.
X bar is the sample mean.
Yeah.
So it should be 177.6 minus 185.
That's some genius thinking right there. So, yeah, sample mean is X bar. Woohoo! That could have been bad. What does it come out to be?
I just did it once. I'm going to double check it, but I got negative 1.920.
Yeah, that's what I got.
Your score?
0.92.
1.920. But it's negative. And so it's the same thing as basically the question right before that, where we're going to get the values lower and the values higher to see which ones are more extreme in both directions. So I got 0.055 based off normal probability applet. I can double check to make sure I didn't do anything wrong.
Yeah.
Okay. So, sorry, I missed everything because I was starting to cut out.
No worries. Basically, it's just like the question number 3, where you plug it into the probability applet. And then you're going to take the things that are further away from the mean. So you have your positive and negative z-scores there, and you're calculating the areas on the outside of them. So it should come out to 0.055.
So we're plugging the negative number in?
Yeah.
On the z-score, correct?
Correct.
Yep.
And
then what left and right should be highlighted?
Correct, because it wants to know the values that are more extreme than that in both the positive and the negative direction, it says. So you would click on the outsides.
So 0.358.
Is that what you got? I got something different.
I got 0.55.
Yeah, that's what I got too.
Plugging in negative 920 on z-score?
You're plugging in negative 1.920.
Oh, 1920. Whoops.
Yeah.
That's what I'm missing my number. Okay, now I'm getting 0.55.
Okay.
Yeah.
Do we all agree on that one? Do we have any questions? Because I don't want to move on until I feel like we got it, just so we're all in agreement.
So setting up the equation's pretty good. Just remember x bar is the sample mean, not the other way around. Do we know what sides to shade?
Because like the thing it says is find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. So it says above or below the mean.
Okay, well, I guess because this one indicated it.
Yeah. I think just if it wants something as extreme, you know that's how far it is from the mean. And you have to consider there's a positive z-score for that as well. That'll be just as extreme but in the opposite direction.
Okay.
I think that's why it reminds us, like, hey, make sure you do the positive part too, because it's included in the extreme values.
That makes sense.
That was a nice little note, though, from him. I appreciate that one.
Yeah. Okay. That's all the question I had.
Number 5?
Number 5, which following will have a smaller standard deviation if 9 observations were randomly drawn from a population. Shoot. Smaller standard deviation. What is this question asking? Which of the following? A smaller standard deviation of 9 observations drawn from a population. Wouldn't it be 5? I don't know. Or number 5 would be C?
Yeah, because, well, that's what I would think, because there's no information. How do we know, based off the 9 observations, what the distribution would be, whether it's the mean or the other thing?
Well, that's such a weird question. If 9 observations are drawn randomly, comparative to what? Nothing.
Yeah.
I thought it was going back to number 4, but it's not. So.
Mm-mm. That's just a random question. I'm going to say that it's not determined.
What do you think, Brandon?
Unless Brandon can prove me wrong.
I'm looking at the notes. I'm trying to figure out what that question's asking. I don't really understand it. The only thing I can think of is that if I originally leaned towards the same thing as well, where I didn't think it could be determined, but I don't really know what it's asking. So I'm like going through the notes and any sort of hints or anything. Let's check this.
See, if we had the mean and the standard deviation, then we'd be able to tell which one, would. would be the outcome, but
Okay. I think I have an answer.
Okay.
Possibly. So the deviation, maybe not. I don't know. Because if you go to like the very first section, it says for the mean of draws from a random variable with mean mu and standard deviation, whatever you call that thing, the following are true. The mean of the random variable x bar is mu, and then it says the standard deviation of the random variable x bar is the deviation divided by the square root of that. So if you, I'm not sure if that's what that's explaining. Like the.
But neither of those are possible answers. Not like specifically, they don't even like relate necessarily because we're trying to figure out whether it would be the distribution of means or distribution of observation, not whether the mu and standard deviation are together. We don't have either of that, or we only have the standard deviation information.
So if you So are the observations the samples they take?
Yeah. They're randomly drawn samples from the population.
So if you have a sample, can you find if you only have samples, can you find a population of anything? Or you'd have to have more information?
From what I've read, you'd have to have more information. But I could be missing something, but...
Because if you only had a sample, you couldn't tell if the population was greater or smaller.
No.
So if it's a smaller standard deviation, does that mean it's more normal skewed? I'm just trying to think.
I don't know.
Nothing on the homework, not the test, but the individual preparation really had anything
Nope.
about that either.
The only thing I can really find that makes any sense, I don't even know if this answers the question, to be honest, but I'm just going to spit it out. In the last lesson 6, it talks about mean and standard deviation of the distribution of sample means, which is kind of related. It talks about the deviation being related to the distribution. The following facts are always true. They do not depend on the central limit theorem. They do not depend on the sample size. These facts hold for the sample mean x bar of any simple random size or sample of size n drawn from a population with mean, mu, and standard deviation. What is the name of that symbol for deviation?
Sigma?
Is that what it is, sigma?
Yeah.
Okay.
Because it's sigma.
It says mean of the samples is mu, which we've discussed, and it says the standard deviation of the sample means is sigma over the square root of the sample, which is exactly what we just discussed in the last one. But it talks about the deviation of the population mean is just sigma, but the standard deviation of the sample mean is sigma over the square root of the sample size. So if you, I guess one way to think about that, like if you have sigma for the first answer, the distribution of individual observations, which wouldn't, that's not the mean though, dang. Okay, never mind. Distribution of individual observations. Yeah, I don't think there's a way to determine it. Now that I think about just looking at the first answer, there's no way to determine how each of those individual observations are distributed unless we had the actual points. Right?
Yeah.
Could you assume anything if it was... I don't think you could even do that without a number.
Yeah. I think so. So I'm for the last one. This cannot be determined from the information given.
Okay, number 6.
Which of the following results implies the spread in x bar decreases as the sample size increases? So x bar is correct.
The law of large numbers.
Yeah, x bar is...
The form result implies that x bar spread in x bar decreases as size increases.
The law of large numbers basically says that if the sample size is increasing, the standard deviation of the sample mean will get smaller. This is basically saying that, except it's flipped, saying that it decreases and the sample size increases.
Agreed.
Law of numerus grandes.
So.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with mean 150.8 and a standard deviation of 8.8. Use this information to answer 7 through 10. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diana's score? We just take okay, so sigma 8.8 over is that what we're doing? Are we just plugging in the standard deviation equation?
I believe so. If she's the only one, then square root of 1 would be 1, I guess.
So is it 8.8 over 160, root 160?
No, that 160 would be 160 minus 150.8.
Yeah, over whatever.
So 2.901.
2.091.
Or, yeah, 2.901. What did you guys get?
1.045.
Wait, did you plug it in already? Which is a z-score thingy?
I got 1.045 too.
It just wants to know the z-score, not any area or anything like that.
Yeah, no, but so for the standard deviation, though, are we just leaving it sigma because we don't have like a sample size or anything?
I would think so, because even if you did plug it in for a sample size, she's the only sample.
Yeah, that's true.
Cancel itself out.
So wait, for 7, what equation did you guys use?
Just the value minus mean over the standard deviation, but we're not doing the sigma divided by the square root of anything. We're just doing the sigma.
Oh, that's where I went wrong.
Now for 8, we go and put that into the probability, right?
This person will score above 160 on the quantitative portion of the GRE. Yeah, you plug it in there and you take the right half or the right portion of that.
Just the right side.
Just the right side?
Yeah, just the right side.
So
You want to score higher than that.
0.148?
Yeah,
That's what I got.
0.148.
Wrong.
So now we have a random sample. Well, do we have to find the mean of these 5 first?
Yeah, because we need
yeah.
the sample.
Okay.
Good call.
So
Good call.
160 plus 175 plus 160 plus
So, but that's 160.
160 is what I got.
So we're doing 160. Wait, what is the Z of these students?
So it's basically
So
like
it's
the one
the
we
same
did
thing.
like her Z-score, but except we have a sample size this time to actually do the square root with.
Okay. So it's the
So it'd be 160 minus 150.8 over 8.8 divided by the square root of 5.
Yeah. Okay.
So
divided by 8.8 divided by square root of 5. 2.3, plug it in.
we got 2.338,
That's what I got.
Yep.
and that's their Z-score. And then we're just repeating what we did in the last one. Plug
Point
that
zero.
in, get the higher probability.
So all we're doing is putting in the 2.388.
You get 388 or 338?
I got
Sorry,
3.
338.
Yeah. Yeah, just plug it in there, and then you're gonna get the right half or the right portion again.
It'll be 0,
Higher than your score.
10, basically. 0.010. It's a lot of zeros.
It is 0 and 0. Weird rounding, but it works. 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem. Yep. Okay.
So we're good?
I'm good.
All right. 11. Suppose the GPA 3.5, standard deviation of 0.7. It is well known that this distribution is left skewed. A random sample of n is 81 students will be drawn. All right. What is the shape of the sampling distribution of random variable x bar, which represents the sample mean of the 81 students who are selected? So since it's a huge sample, it'd be approximately normal.
Yep. Agreed.
Agreed? Okay. What is the mean of the distribution? So now we got to find this stuff out.
So.
Wait, wouldn't the mean just be 3.5? Or do we have to do the equation?
I'm just trying to think of what equation we would even use.
I don't think we have a specific equation because we're not going to be using the mu minus, or the mean minus the mu.
Yeah.
It'd
So-
just be the mean.
So it's just the 3.5.
I think so, yeah.
Okay, because I know usually on the past couple tests they've been identify the mean and then do the equations after. So. Okay, so 13. Anyone have any questions on 12, I guess?
No.
Yeah, kind of. So it wants to know the mean of the distribution. So is that like the standard deviation then? Isn't that what that's asking for?
No, because the next
what-
one's asking for the standard deviation.
Okay.
So now it's asking what is the standard deviation. So now we have to plug in sigma over the sample. So 0.7 divided by root 81. Was that it? 0.078?
Where's standard deviation? Is it there? Well, that's the equation for the standard deviation, so yeah,
Okay.
but
Is this like review from last week? This is what it looks like. Or at least right now.
That one you got, what was it again? 0.086?
0.078.
Yeah.
So
it
then
should-
for,
I see what I did.
Are we good for 13?
yeah,
Yeah, we're good.
Oh, okay. So what is the probability that the mean GPA of 81 randomly selected BYI students will be less than 3.3? So now are we doing it on the Z, but to the left? Left of the normal probability applet?
Yeah, so you need to find the z-score for that 3.3 real quick.
Okay. So Z-score is variable. Do we even have a variable? Or what is that? Yeah, value?
Yeah, so that's going to be 3.3.
Oh, okay.
And then the average...
3.3 minus 3.5
Yeah,
Yep.
so you get negative
Yeah.
0.2?
divided by the standard deviation. So negative 2.56.
Yeah.
So just to the left is 0.005. And greater than 3.33 is 0.005. Why are they the same thing? How did you do that wrong?
Two. For 81 randomly selected BYI students will be less than 3.3. So did you, for your answer, for your z-score, you got negative 2.564, correct? So you plugged in the applet. And so that should give you an area of, so scores left of that are going to be less, so it should be probability of 0.005.
Yep. So then the scores above that, though, are the middle and the right, right? Since we got a
Actually,
negative for the actual answer?
Yes, that'd be correct.
So not the left.
No,
Well,
not the left.
that's for 15 on that one she just asked about.
Oh.
0.995.
Yeah. So within the 99% range. Or, yeah. Yeah.
You want to go over our answers?
So this one would be the others, right?
Yeah, the middle and the right.
Which is the same thing.
Wait, 14 is just the left one.
Yep.
Oh, that's why I'm lost. That was my bad.
And yeah, and 15 is the middle and the right.
Okay, so 0.005. Okay, I'm on the same page now.
Okay.
I thought we were still on 14, and I was like, how did that happen?
Sorry, that was probably my fault. I jumped ahead.
No, it's good. Then switch 0.995. Yep. All right. Do we want to read over the answers?
Yep.
Yeah,
Okay,
let's do
so true, 3 is 0.175.
Yep.
4 is 0.055 or 0.055. 5 is cannot be determined. 6 is the law of large numbers. 7, we're doing 1.045.
Yep.
8 is 0.148.
Yep.
9 is 2.338.
Sounds good.
10 is 0.010.
Yep.
11 is approximately normal. 12 is 3.5. 13 is 0.078. 14 is 0.005. And 15 is 0.995. Is that good?
Oh, man. We missed one.
Which one? Can somebody help me understand 12? Maybe I'm just not understanding what the question's even asking.
I'll tell you 12's right.
I know we said it was 3.5. I'm just the mean of the distribution of the sample.
It's just what's a reading. It says that's what the mean is, so it's asking again what the mean of the distribution of sample.
Oh, okay, I see. The mean mu of x bar is the sample mean of the sample means is the pop. Okay, I see it. There we go. Seven. Let me go back. Which one did we miss?
I'll never say. You can never say. Something's gay. Oh, wait, we're still recording. Oopsies.
Oh, I'll stop.